Have you ever driven past those giant spinning wind turbines and just wondered, how does that thing actually make my lights turn on? Well, today we're going to demystify that whole process. We're going to follow the journey from a simple breeze all the way to the electricity that's powering your screen right now.
Okay, so the simplest way to wrap your head around a wind turbine is to think about a fan, but in reverse, right? Your desk fan uses electricity to spin its blades and make wind. A turbine does the exact opposite. It uses the wind to spin its blades, and that creates electricity. It's a really elegant, simple idea, but the engineering that makes it all happen, that's where it gets really cool.
So to really get it, we need to follow the energy from start to finish. First, we'll look at how those massive blades catch the wind's power. Then we'll climb up into what's basically the engine room in the sky. After that, we'll uncover the scientific secret that actually makes the spark. And finally, we're going to trace the path of that electricity all the way to your house. Sound good? Let's dive in.
So, first things first, how do you take something you can't even see, the wind, and turn it into a powerful physical rotation? Well, it all starts with the blades. Now, these aren't just giant paddles. They're actually shaped a lot like airplane wings. We call that an airfoil. As wind moves over the curved shape, it creates a pressure difference. It's the same force, called lift, that lets a plane fly. But here, instead of lifting the whole turbine up, that force gives the blades a powerful push, causing them to rotate and capture the wind's kinetic energy. That's just the energy of motion.
And that kickstarts a really simple mechanical chain reaction. The wind pushes the blades spin the big hub in the middle, and that hub turns a long rod inside called the main shaft. And get this, the tips of these blades can be moving at over 170 miles per hour. So at this point, we've done it. We've turned the invisible force of the wind into some serious spinning energy. Okay, so now we've got this giant shaft spinning like crazy. What's next? Well, for that, we have to go up, way up into that big box at the top of the turbine. That's called the nacelle, and you can think of it as the powerhouse, where all the magic really happens.
Inside the nacelle is the absolute heart of the entire operation, the generator. Its job is super important, but it's also pretty straightforward. It takes all that spinning mechanical energy from the shaft and it converts it into electrical energy.
A perfect way to picture this is with one of those old-school bicycle lights, you know? The ones powered by your pedaling. You pedal, the wheel spins, and a tiny little generator, a dynamo, lights up your headlight. The generator in a wind turbine works on the exact same principle, just on a massive scale. The faster the wind blows, the faster the blades pedal, and the more electricity you get.
But wait, how does a generator actually make electricity just by spinning? It kind of feels like magic, doesn't it? But it's not. It's all based on a fundamental law of physics. So let's pull back the curtain and look at the science behind the spark. The fancy scientific name for this magic is electromagnetic induction. I know it sounds a little intimidating, but the core idea is surprisingly simple. And what's crazy is that this one principle is how we generate almost all of the electricity we use on the entire planet. So here's how it works inside that generator. That big spinning shaft from the blades, it's turning a set of really powerful magnets inside giant coils of copper wire. And here's the key. A moving magnetic field has this amazing ability to push the electrons inside that wire. So as the magnets spin past the wire over and over, they create a constant push, forcing the electrons to start flowing in a single direction. And a steady flow of electrons, well, that's exactly what electricity is. So really, when you boil it all down, if you forget everything else, just remember this. All of that complex machinery, those blades bigger than a jumbo jet, it all exists for one simple reason: to spin magnets past wires. Moving magnets make electricity. That's the whole secret.
We did it! We've made electricity. But our journey isn't quite over yet. Now we have to get that power from the top of a turbine in the middle of a field all the way to your light switch.
See, the electricity coming right out of the generator isn't ready for a long trip. To travel hundreds of miles through power lines without losing a bunch of energy along the way, its voltage needs to be cranked way, way up. And to do that, you need something called a transformer.
So here's the final leg of the journey. The power gets made in the turbine's generator. It then goes down to a transformer at the base, which boosts the voltage up super high for travel. From there, it goes to a substation, where it joins up with power from all the other turbines. Then it zips across the country on high-voltage power lines. And finally, right before it gets to your neighborhood, another transformer steps the voltage back down to a safe level for your home.
So let's just recap the whole thing one last time. The wind's kinetic energy gets caught by the blades. That motion spins a generator.
Inside that generator, moving magnets push electrons through wires. That's electromagnetic induction. And finally, that electricity gets sent out onto the grid and delivered right to us, from wind to wire to you.
And there you have it. It's a pretty incredible journey, right? From a simple concept like a fan in reverse, all the way to the elegant physics of electromagnetic induction. It's an amazing piece of engineering that takes nothing more than a breeze and turns it into the power that runs our entire world. Kind of makes you wonder, now that we've figured this out, what's the next giant leap for wind power going to be?